Hey guys. Okay, we're going to do just a brief introductory thing here on average velocity versus instantaneous velocity. And I do mean very brief. Okay, so average velocity, we said in the last video, was equal to the slope. And now I'm telling you instantaneous velocity is equal to the slope. Huh? What? Okay, I think we can both agree, all of us agree, that we have a whole lot going on this graph. It's not just one nice smooth line. If it was one nice smooth line like we looked at before, then we would have the slope equal to the average velocity. Okay, so if we were looking at something like this, where it's just one nice straight line, average velocity, slope, no problem. When we start looking at something like this graph has a lot happening. Okay, the object starts off moving at a pretty good clip. It covers 80 meters in the course of about 20 seconds. The object then comes to a dead stop and stays right there at 80 meters until it hits 40 seconds of time. So for 20 seconds, it's just sitting there. And then it takes off again. And from the time of 40 seconds to a time of 100 seconds, it covers from 80 meters to 200 meters. So when we start seeing this discontinuous line where it's not just one nice long smooth straight line, we have to look at it in chunks. Okay, so average velocity only works for slope. Slope only works for average velocity. It's one long continuous line. If one slope only. Instantaneous velocity would be, well, we could find the instantaneous velocity of the first section. We could find the instantaneous velocity of the second section. And we could find instantaneous velocity of the third section. So what happens is we start zeroing in on smaller fragments of what's going on, smaller instances, smaller instants in time. So instantaneous velocity is the velocity in a given instant. Okay, and we're just going to use algebra for this class, but when you get further on in physics and further on in math, that's where calculus becomes really important, because with calculus, we can shrink that period of time down until it's almost infinitely small. Okay, and that helps us to calculate really fast changes in velocity. But for anything that we do in high school physics, including AP physics, we really only need to focus on using algebra. And so we just focus in on segments. Okay, so for the period of the first chunk there, instantaneous velocity for segment 1. Well, we're going to find the slope of segment 1. Okay, not anything really hard there, right? We're going to do 80 meters minus 0 meters over 20 seconds minus 0 seconds. Cool. So 80 divided by 20, I think we can all agree that the instantaneous velocity, or v, for that given period is 4 meters per second. Specifically, it's a positive 4 meters per second. Okay? Not hard. We just separate it into a little segment. Okay? For velocity 2, so we'll call this velocity 1. For instantaneous velocity 2, and I'm going to note over here, instantaneous. I'll just say instant. Instant velocity 2, we're going to do the same thing, but we're going to do it for segment or line segment 2. Okay? So for that, slope of segment 2, well, it's at 80 meters. It's going to stay right there at 80 meters the whole time, right? And then it winds up at a time of 40 seconds, And it started doing that at 20 seconds. So we're going to say 40 seconds minus 20 seconds. 80 minus 80 is 0. So the instantaneous velocity for segment 2 is 0 meters per second. Okay. Then we need to look at segment 3. I'll bring in a blank piece of paper here. I'm running out of space. Okay, if we look at segment 3, so for instantaneous velocity 3, okay, and we would just write V3, but I'm saying instant just to keep that in your heads. So this is the instantaneous velocity. Okay, so we would say it starts at time 40, ends at 100. So we're going to do slope for segment 3. 100 seconds minus 40 seconds on the bottom. And let's see, at 100 seconds, it's made all the way to, let's see, is that 200? Yep, all the way to 200 meters. And at 40 seconds, it was back here at 80 meters. So minus 80 meters. So let's see, if we do the math on that, 200 meters minus 80 meters, well, that's 120 meters over 100 minus 40 seconds, 60 seconds. Hey, that's a pretty happy number. 120 divided by 60, 2 meters per second. And it's implied that it's a positive. I mean, 200 minus 80, it's a positive, right? So we can put a positive on there or we could leave it off, but I'll throw it on there just to note that it's a positive velocity. Okay, given this line, how in the world are we supposed to calculate average velocity? There's no one slope. Well, there's a couple of different ways to do it, but the easiest way, and you know me, if there's an easiest way, I'm taking the easy way, okay? All right, so the easy way to do it is to just look at overall from time 0 to time 100. So we're going to do average velocity for the whole trip. From 0 to 100 seconds, so 100 seconds minus 0 seconds, it covered a distance of, well, started at 0, went to 200, so 200 meters minus 0 meters. Well, gee, 200 minus 0 is 200. And 100 minus 0 is 100. Aren't these nice, happy numbers? All right, 200 meters divided by 100 seconds, 2 meters per second is the average speed, or sorry, the average velocity for this object. Well, wait a minute. We just said the instantaneous velocity for part 3 was also 2 meters per second. Is it always going to work out like that? No. No, it's not always going to work out like that. It just happens that if we were to take all of those velocities at every instant in time and average them all, well, looking at the velocity for part 1, it was at 4 meters per second. Then for part 2, it sat there at 0 meters per second. And then again for part 3, it wound up going at plus 2 meters per second. It just happens that for the overall trip, it wound up also being 2 meters per second. But that's not a guarantee, not by any means. Okay? It could have easily wound up being something like 1.5 or, and none of the numbers have to match. That's not what we're looking for. Okay, but it can happen, so don't let that throw you either. You have to calculate each of these segments individually to find your instantaneous velocity, and then to find that overall average velocity, find the total distance covered, and divide it by the total time that it took to cover that distance. Okay, and remember, we have to account for if the distance was in the positive direction or in the negative direction if we're dealing with velocity. Happily, this one was positive. Let's just go with simple for now, right? Okay, that was the intro for the day, and I hope that you guys have a great rest of the day, and I will see you after a bit.